All right, so we're on to chapter 15, and we're now talking about water. Water is obviously important for every living thing on Earth, and there's a lot of issues that go along with it. So this first chapter is about freshwater and all the issues that go along with freshwater, and then next chapter we'll move into the marine system, so all of the oceans and the salt water on the planet. So your book starts off by saying, with a quote, "Water, water everywhere, nor any drop to drink," which actually kind of well describes the situation of water on our planet. Because the majority of the Earth's water, so almost 98%, 97.5%, resides in oceans, which we cannot drink and we cannot water our plants with. So, if you remember back to biology, we need to have, we cannot have a hypertonic solution. So that's why salty water doesn't work for us. So only 2.5% is considered fresh water, so water that is relatively pure and free from salts, and only 0.1% is available for human use. So this is a diagram showing where the water availability is. This is all of the water, and that tiny sliver is the fresh water, so the water that has a low enough salt content. All of the fresh water here, 79% is frozen in ice caps and glaciers, and the other 20% is in groundwater. And so that last 1% is surface fresh water, and that's found in lakes, soil moisture. This sliver right here is atmospheric water vapor. Then we have rivers and water within organisms. So it's a very small percentage of all the water on the planet. So water is renewed and recycled as it passes through the water cycle. So we start with precipitation, where water falls from the sky, sinks into the ground, or acts as runoff to surface water bodies, like the ocean or large lakes. Then the rivers interact with ponds, wetlands, and coastal aquatic systems, and underground aquifers exchange water with surface waters. So those are most of the movement that's happening within the water cycle. And the movement of the water cycle creates a web of interconnected freshwater and marine aquatic ecosystems that exchange water, organisms, sediments, pollutants, and other dissolved substances. So water is how basically everything gets from place to place. All those things, the pollutants, which is not a great thing, but sediments and other dissolved substances. So water is a method of movement for them. So what happens in one system affects others even super far away. So this is a good diagram to show that. So we have water in all these places up here. Groundwater springs feed river water. So rivers flow from mountains, usually where ice melts. That's how the water gets there. Then it'll move through different lands, and pesticides and fertilizer will enter the groundwater and the surface water. We have freshwater wetlands. We have water taken out for irrigation will reduce the river flow. We have a reservoir built by a dam that's blocking the river flow. It also traps sediments in the reservoir. We have groundwater flowing into every river and into every ocean. We have urban and industrial pollutants entering bodies of water. We have agricultural pollutants and eroded soil. So there's sediments moving in all of here too. It's constantly, so something that happens up here may affect an organism down here. So all the water, because of how much it moves, has a very wide-reaching effect. Then we have groundwater. So groundwater plays key roles in the hydrologic cycle. So surface water is located atop the Earth's surface, as found in a river or a lake. So water that you can see on the Earth is surface water because it is above the surface. Groundwater is beneath the surface, and it resides within pores in rock or soil. So it's kind of like a sponge. So if you think of the groundwater as a sponge is a solid thing, but water can fill in the pores inside of it. Any water that doesn't evaporate, flow into waterways, or get taken up by organisms will infiltrate into groundwater. So it's kind of what's left over, and then it fills in the pores in the soil. And groundwater can remain underground for thousands of years at a time. So, and the groundwater is moving too. It's going to move from areas of high pressure to areas of low pressure. So basically, if you think of I'll come up with an analogy later. But basically, if you put a lot of pressure on something, the water is going to want to move. So the water is moving within the groundwater as well. So all this groundwater is stored in what's we call aquifers, which are porous sponge-like formations of rock or sand. So not all of the material underneath the Earth's surface is going to be able to hold groundwater, but some can hold it better than others if it's porous and sponge-like. So this diagram here shows where the groundwater is. And so we have the upper layers right here contain pore spaces partly filled with water. So it's a a little filled, not entirely. Down here, in the lower layers, it's almost entirely filled with water. And the boundary between these two, or even right here. So this is filled with water. Up here is not entirely filled with water. Up here is not entirely filled with water. The barrier between where it's entirely filled with water and where it's not is called the water table. So you can see it labeled right there. So the way that you can think of it is think about a sponge if you put it partially submerged, like in a Tupperware with water. The water below will completely fill up the sponge. Up top, there will still be pores in it. And that water level between where it's filled and where it's not is the water table. So the upper border of the layer completely filled with water is the water table. So there's the water table. Any area where water can infiltrate through the surface and reach the aquifer is a recharge zone. So that means anywhere it can go from the surface and get down to the groundwater is called a recharge zone. So we have anywhere where it reaches the surface and can get to the groundwater would be a recharge zone. We also have these things called confined aquifers, which are trapped between impermeable clay. So that down here, these aquifers are storing water, but we can't really get to them because they have this upper confining clay layer versus this is an unconfined aquifer up here. We can access it through a well. It's easier to access through a well. And so that is a recharge zone right there. The reason for this is because the earth consists of layers of material with different textures and densities. So the material right here is going to be different than this clay layer, different than this aquifer right here, different than this clay layer down here. And the water in the confined aquifer is under a lot of pressure. So an unconfined aquifer has no impermeable top layer, meaning that water can get to it no problem. And so it's under less pressure and can be recharged more easily. The largest known aquifer is the Ogallala Aquifer, which is located on the Great Plains of the United States. But water is being withdrawn really quickly from this, much faster than it can be recharged, which is resulting in reductions of its volume in many places. And the reasons for this is because that is where we had a really, really bountiful and fertile farmland, and we were able to draw water from there to irrigate it. And because of that, we've used it more than it could renew itself, which is why it's running out. So surface water converges in river and stream ecosystems. So surface water is vital for our survival and for ecological systems, as I'm sure you could imagine. We need those bodies of water for ourselves as for all of the ecological systems. And so the surface water that's in a body of water that we can see on top of the Earth's surface becomes groundwater by infiltration. So basically, it will just seep into the layers of Earth below and become groundwater. Vice versa, groundwater can become surface water through springs, which is where the groundwater reaches the top and creates a body of surface water. It keeps rivers flowing and wetlands moist even in dry conditions. So even if there hasn't been a lot of rain, the groundwater will keep those wet ecosystems alive because there's water stored underneath. Groundwater and surface water constantly interact, and water is constantly flowing between them. So water that falls from the sky, precipitation, or melts from snow or a glacier that flows over a land surface is called runoff. So any water that hits the Earth's surface and then flows is runoff. Runoff converges in low-lying areas. So if you think topographically, so how the Earth's surface has different levels, like mountains are high and valleys are low. The water is going to run down, and it's going to converge in a low-lying area, forming streams, which can then merge into rivers, which eventually become a lake or an ocean. So there's a bunch of different names for these sorts of things. So an area of land drained by a river system and all of its tributaries makes up that river's watershed. So first, let's talk about river system and tributaries. Tributaries are smaller rivers that feed into a bigger river. So you can think of it as a stream. They're just small bodies of water that eventually feed into a big one. And then the river system is the main river and all of its tributaries. So all the tributaries in the main river are getting its water from a very large body of land, and the land has runoff happening, and it gets to that river system, and so that's the watershed. So basically all the land where a river gets its water from through runoff is called a watershed. It can also be known as a drainage basin if you see that anywhere. So a river that flows, now we're going to talk about a few different types of rivers. So the landscape determines where the rivers will flow because, as we talked about, gravity is what makes these rivers flow, right? They're flowing downstream. So the landscape determines which is the lowest part and where the water will flow. So the landscape determines where the rivers will flow, but the rivers can also shape the landscape. If you think about it, it's not an example here, but the Grand Canyon in the United States was carved out by rivers because as the water moves through, erosion happens and we lose, it carves out the landscape. So we have a couple of different kinds here. We have what's called a braided river, which is where there's a deeply sloped region and it carries a lot of sediment, and so it ends up looking like this. It's an interconnected series of watercourses. Then we have a meandering river, which are found in flatter regions, and they start to form bends, and the bends get larger and larger because as it goes around the big curve, the outside gets more eroded and the inside gets deposition built up. So we get these like really curving roads. You probably can't see this picture, but the most exaggerated shape is called an oxbow river, and it'll just form like a complete, almost like a horseshoe from a meandering river. So over thousands or millions of years, the shifting course of a meandering river can carve out a flat valley. And areas near a river's course that are flooded periodically are within the river's floodplain. So basically what that means is frequent flooding and deposition of soil make floodplains soil especially fertile. So as a river will get occasionally flooded because of extreme weather, or maybe as the snow melts or whatever like that, it floods the land around it, and that's called the floodplain. And that is extremely fertile because as it fills with water, it gets all the good nutrients and everything and all the soil that it needs to be super fertile. So agriculture thrives in floodplains, and riparian forests near riversides are especially species rich. So riparian means that it is goes through periods of flooding and drainage, which allows it to have that floodplain fertility. So the riparian forests near a river are going to be especially species rich because they have very fertile soil. Lakes and ponds are ecologically diverse systems. So lakes and ponds are bodies of standing surface water. You probably already knew that. Really, really big ones can be known as inland seas. For example, that would be like the Great Lakes. If you've ever been to Chicago or been around any of the Great Lakes, it looks like the ocean, and there's waves too, which is weird. The Lake Baikal, which is in Asia, is the world's deepest lake, just over a mile deep. And the Caspian Sea is the largest body of fresh water that covers as much land as the area of California.